So if this is a bit complicated, then luckily Keras supports all this functionality in one single layer, which is called embedding. So embedding takes an input of a certain dimension and actually creates a low dimensional representation for us. So now we have a vocabulary of 1,000 possible words, and we have 3 sentences, and each sentence contains exactly 5 words. So no need for padding in this simple example. And this should give us a 3 by 5 matrix, which is actually correct because we have 3 sentences and 5 words per sentence. And instead of words, we have integer representations of the words. So this is actually correct here. So the output is of shape 3 by 5 by 3. So it's a 3D tensor. Again, we have 3 sentences and 5 words per sentence. But now each word is not represented as a single dimensional integer scalar, but it is represented as a vector of size 3. Because we defined that we will compress this high dimensional space into a lower dimensional space of size 3, of dimensionality 3. So let's actually inspect this tensor. So the first element here is a sentence, and it's a list of words, and each word has 3 dimensions. So now we have understood how the embedding layer works, and let's use this layer to create a very simple document classifier. We want to classify the sentiment of a text, whether it is positive or negative. So this document contains a couple of sentences. They are relatively simple. So we have 5 negative and 5 positive sentences. And we assign a class label to each sentence. 1 stands for positive and 0 stands for negative sentiment. And again, we use the so-called one-hot encoder from Keras text, which in my opinion again is not a one-hot encoder. It just gives us an integer representation for each word. So for example, 29 is work, and you see work in 2 sentences. And now we are padding, because our longest sentence has 4 words, we are padding to 4. That means the shorter sentences are just padded with trailing zeros. So now let's create an embedding. In this case we will reduce the dimensionality to a dimensionality of 8. The max length is 4. And then we are flattened because we don't want to work with 3D tensors. And then we will feed in the result into a dense layer, which has only 1 dimension, because we are predicting a binary target, 0 or 1, and therefore we also use the sigmoid activation function. Use Adam as optimizer and binary cross entropy as loss function. So note that the embedding layer has already 400 parameters. So now it's time to call fit, and note here we have the padded one-hot encoded sentences as input and the class labels as target or as output to the neural network. We are training for 50 epochs, and immediately we measure accuracy. So we are at 80%, which is not bad, but we can improve this of course. And now let's create a little overview how good we are doing per sentence. So we call predict, which gives us the output of the sigmoid activation. And in the second column, we just use the actual label. And as you can see, in most of the cases, the prediction is correct. So wherever we see a 1, the value is bigger than 0.5. And wherever the value is 0, it's less than 0.5. So you see that actually works. Whenever the class label is 1, you see an activation bigger than 0.5. And in most of the cases, when the class label is 0, you see an activation which is lower than 0.5. So this is only a little example, but that's actually the way how document classification is done in real-world scenarios.